Hey there, math wizards. Are you ready to unlock the secrets of calculus and dive into the captivating world of derivatives? Imagine this. You're cruising down a winding road, and suddenly, you wonder how fast your car is accelerating at any given point. Ever pondered over the slope of a curve or how to find instantaneous rates of change? If you're curious about the benefits of understanding basic concepts in learning, you're in for a treat. Welcome to Gifted Academy Tutor's Epic Grade 12 Calculus and Vectors, MCV4U series. In this video, we're about to embark on an exhilarating journey where we introduce you to derivatives, the key to understanding how to take the derivative of a function. But why is this topic so exciting, you ask? Well, derivatives are everywhere, from calculating motion in physics to predicting financial trends. Understanding this essential concept will equip you with a superpower to conquer various real-world challenges. Now let's get into Lesson 3, Part 1, where we dive deep into the world of derivatives. Oh, and hey, we know you might be watching this on YouTube, Instagram, or TikTok. So here's what you can do to be part of our incredible community. Follow, double tap that share, and don't forget to subscribe. Because at Gifted Academy Tutors, you, our awesome viewers, come first. Your growth and learning are our top priority. We want to reach and inspire as many curious minds as possible. So, stay tuned as we unveil the wonders of derivatives and how they shape our understanding of the world. Ready to join us on this exhilarating ride? Then let's buckle up and hit play. Don't miss a moment of this thrilling adventure into derivatives. Keep watching to grasp the fundamental concepts and get ready to level up your math skills like never before. Let's embrace the power of calculus and uncover the magic of derivatives together.
Now we starting the topic, Introduction to Derivative. In this topic we will get to know how we define the derivative from the first principle. So the first topic is first principle definition of the derivative. In the first principle definition, we have a function fx and we want to find out the first differentiation of that. The derivative of a function fx is a new function it is called f dash x, or the first derivative of fx, and it is defined by the f dash x is equal to limit h approaches to 0 fx plus h minus fx, which is divided by h, and here this limit should exist if this limit exists. Now we are doing one example using the first principle. The example: use the first principle definition to determine the derivative of fx is equal to x square. So for the solution of this example, we have given the function which is fx is equal to x square. Now we are applying the first derivative principle, so we can define f dash x as limit h approaches to 0 fx plus h minus fx over h. So here we are substituting the values in the function. So we have limit h approaches to 0 fx plus h square minus x square over h, as we substituted the x plus h into the function and fx into the function. Now limit h approaches to 0, we are expanding the x plus h square, so it becomes x square plus h square plus 2xh minus x square h. It becomes limit h approaches to 0 h square plus 2xh over h, which becomes limit h approaches to 0. If we take common h, it becomes h plus 2x over h. Now we are having limit h approaches to 0 h plus 2x. Now we can substitute h equal to 0 in this expression, so this becomes 2x plus 0 and it is 2x. So the f dash x we get is 2x. So here this is the f dash x using the first principle. Now we are doing one more example. Use first principle to differentiate fx equal to x cube So for this we have the function fx equal to x cube. Now using the first derivative principle, so f dash x is defined as limit h approaches to 0 fx plus h minus fx over h. Here we can substitute the x plus h in the function, that becomes x plus h cube minus x cube over h. Now we can expand x plus h whole cube, which becomes x cube plus 2x square h plus xh square plus x square h plus 2xh square plus h cube minus x cube over h. If we simplify this expression, we get, here it is, h approaches to 0. We get 3x square h plus 3x h square plus h cube over h. We can take an h common here. It becomes 3x square plus 3xh plus h square over h. So limit h approaches to 0. 3x square plus 3xh plus h square. We can substitute h equal to 0 in this expression, and then we'll get 3x square plus 3x 0 plus 0 square, which becomes 3x square. So first derivative will become 3x square. Now we will discuss the Leibniz notation for the derivative. So Leibniz, it expresses the derivatives of the function y equal to fx as dy by dx. It is written as dy by dx. Leibniz's form can also be written as the first derivative of the function is also written as dy by dx. Also, the expression dy by dx at x equal to a in Leibniz notation means determine the value of derivative where x is equal to a. Now we are taking one more example. The given function is y equal to 1 over x and calculate dy over dx. So this is the Leibniz notation we are using here. So how we can do that? To calculate dy by dx, we can use the first principle, limit h approaches to 0, fx plus h minus fx over h. So if we substitute the values, we'll get limit h approaches to 0, fx plus h becomes 1 over x plus h, fx is 1 over x over h. If we simplified it, limit h approaches to 0, we can take x minus x plus h over h into x plus h. It becomes limit h approaches to 0 minus h over h x into x plus h. It becomes limit h approaches to 0 minus 1 over x plus h. If we substitute the h value as 0, it becomes minus 1 over x into x plus 0. It is minus 1 over x square. So we get dy by dx as minus 1 over x square. So this is how we can use the first principle and the notation, Leibniz notation. So this is basically the differentiation of the fx.